So first we will learn about fx is sine of x. Okay, so we will try to find how to plot a few of trigonometric functions, and for that what help do we take? So we will take help of a circle, okay, where this is the angle is represented in counterclockwise direction. So let's say we have, this is origin, this is P, and a perpendicular like this is M. Okay, so this side is positive, okay, this side the length is positive, in this side the length is negative, so OM is positive on this side, so this OM dash is negative, this M dash P dash is positive, MP is positive, but let's say P dash dash M dash dash, so P dash dash M dash dash is negative. Okay, so this way we see that, okay, OM on the positive side it's positive, on the right it's negative, on the left it's positive in upward direction and negative in downward direction. So we will try to now plot the function sine x. Okay, so even though most of you will be knowing what is the plot like, but we will try to plot so that you never forget also. So 0, some of the important values, pi by 2 is this, then pi, okay, and minus pi by 2 and minus pi. Okay, so if we plot, so let's see what is the sine of x is MP by OP, isn't it? It is MP by OP sine x, if this is of course x. So now what happens at 0, MP value will be 0. So, and let's say OP is just the distance, radius, so it is always A. Okay, so MP is initially 0 by A, so it is 0. Okay, and then sine of pi by 2, what happens here, it comes. So now MP is what? MP is equal to the whole of radius, and this OP is always A, so this is 1. So sine pi by 2 is 1. So now we know that, okay, sine of pi by 2, so it, and in between if you see, so at let's say sine of pi by 4, so it is MP and OM are equal, so it is, so no, so it is, what happens, MP and OM are equal, but this is, so 1 by root 2. So here the value goes something like this till pi by 2. So for pi by 2 till now we have to look towards pi. So what happens, we see that, okay, here also MP is positive and OP is always positive, so it will be, so something like this, at pi it will be, MP will be 0, so it comes something like this. Okay, now this is 3 pi by 2 to 2 pi. So what happens here, so if we go in this direction, so here what happens, and at this place we see the value, this is negative, MP is negative by something, so we know that till 3 pi by 2 it will be going in negative direction, and in fact from 3 pi by 2 to 2 pi also it is negative. So at least we know from here to here it is negative. Okay, and its maximum will be where, at this pi by 2 to then pi 3 pi by 2, the value is what, so this place MP and OP are equal, so it becomes -1, and here again it becomes, MP becomes something negative but very small tending to 0, so it becomes here like this. So we see this is the function of sine of x, and we plotted using this circle. Okay, and if you use this, so it was one example, small example, easier example, but you can plot for difficult functions like tan of x. Let's say we want to plot for tan of x. So what is tan of x? F of x, let's say, is tan of x. So it is sine of x by cos of x. Okay, and in fact we now again draw the figure. So let's see. So we draw the figure. This is O, this is M, this is perpendicular, so something like this. This is x. So now what is tan of x from this? So it is MP by OP. Okay, so now again we will try to plot it for various values. So 0 to pi by 2, pi, okay, and let's say minus pi by 2, minus pi. Okay, so if we are plotting this, so let's see it is MP. So in first quadrant, let's see, so MP by OP. So MP initially at 0 is 0 because it's no height there. Then MP is increasing as x increases, so MP is increasing, and when x becomes pi by 2, MP is maximum. So we see MP is increasing in 0 to pi by 2. Okay, but what about OP? So OP is initially when x is 0, so it is maximum, it is equal to that A, the radius of the circle. Okay, so this is A, let's say. So OP, but it's constantly then decreasing, because if this is the case, this is OP, but if x increases, so OP dash, so it becomes smaller. So OP is decreasing in 0 to pi by 2. So now let's try to find the values. So tan of 0 is, so 0 by, so it's 0 value by A, so it's 0. Tan of pi by 4, then MP and OP are equal, so it is 1. Tan of, now let's say, pi by 2, so what happens? MP becomes 1 and OP becomes 0, it's tending to 0, so it becomes infinity, so it's tending to infinity. Okay, so this way we see 0 to pi by 2, it's going from like this. Okay, so asymptotically it becomes 0 to pi by 2. But then if we see on the other side, so what is happening? MP. So here what happens now? MP by OP. So here again it's very high value, but OP is now negative. Okay, so this side OP is negative. So it's suddenly the value at greater than pi by 2, it becomes something very near to minus infinity, and at pi again it comes and MP becomes 0 and it becomes 0. So this is the graph for tan of, okay, tan x. So as you see, if you use this, so you will easily find the graph of tan x and any trigonometric function. Let's say now sec of x, so that will be even a better one.